This is a short presentation of a study we presented in Euroguss 2022. This work was carried out by 3 companies, which were Electronics GmbH, Vestalpin and Asterland. From a previous study that we presented 2 years earlier in Euroguss 2020, we stated that the typical variables that we are dealing in high-pressure die casting fell short of representing the actual data or phenomena that are happening inside the cavity. Therefore, we need to place the sensor closer to the phenomena that we need to measure, and normally additive manufactured inserts are placed in the most relevant areas of the die, so mixing both concepts seems the way to go. In case study 1, an IM distributor was produced to reduce cycle time, and we add 5 sensors on it. We don't advocate for so many sensors for production. This was an R&D case. Okay, we have an image of the insert and the wires coming out of it. Those wires were centralized in a cabinet, and from here to the electronics monitoring systems. And the electronics monitoring system calculated the variables. It is worth noticing that by measuring the temperature of the insert, we have much better data than if we measure only the water temperature and maybe flow. Because, for instance, having issues with the water line or calcareous depositions inside the insert, that may cut by 40% the heat transfer between the insert towards the water. Case study 2, another insert was produced. In this case, it was a quality related issue. We wanted to solve shrinkage and die soldering. And we add also 3 sensors on it, and one of them was built in the insert, so Electronics GmbH weld the sensor in the insert, and this was a CVT sensor that is providing fast reaction data in contact with the aluminum, and thanks to that we are able to test or to see the surface temperature of the insert and detect the metal from front arrival. Thanks to those signals, we were able to discover phenomena that they are not intuitive to think of. And by designing the insert taking into account the sensors, cost can be reduced. So the architecture that we are advocating, we have sensors and signal from those sensors that goes to a system, and this system they are processing those signals and creating the variables. Those variables go to the centralized system that makes able to the big data. This centralized system can be further connected to other areas of the company. So going to specifics, Vestalpin provides us the tool steels and the additive manufactured inserts. Electronics GmbH provides us the sensors and the monitoring system that make the work with the signals and produce those variables in a uniform way, no matter what kind of machinery or brand or generation it is. And those variables are sent to a centralized system, and here Asterland proprietary Salomon software is making the big data relation between inputs variables and output variables, for instance a leakage test after machining. And the results of those big data calculations and analysis are shown to the die caster by Sentinel in a friendly manner that foundry men can understand. So, good data presented in a clear way promotes fast problem solving and helps building knowledge. For further details, please contact Asterland's Light Metal department. Thank you.